Hello and welcome. Today, we're diving into a core concept in Python that often confuses beginners and even seasoned developers: copying. Specifically, we'll explore shallow copy versus deep copy. In Python, when you assign one variable to another, like b equals a, you're not always creating a new, independent copy of the data. Instead, you're often making both a and b refer to the same object in memory. If that object is mutable, changing it through will also be reflected when you access b. This behavior is perfectly fine for immutable objects like numbers or strings, but it can lead to unexpected side effects with mutable objects, such as lists, dictionaries, or custom classes. To truly separate data, we need to make a copy. Python provides two main types of copying: shallow copy and deep copy. Each serves a different purpose, and understanding their distinction is vital for writing robust and predictable code. Let's start with shallow copy. A shallow copy creates a new compound object, but it doesn't recursively create copies of nested objects. Instead, it inserts references to the nested objects found in the original. Think of it like making a new folder that contains copies of the main files, but for any subfolders, it only contains a shortcut pointing back to the original subfolder. There are several ways to perform a shallow copy, depending on the object type. For lists, you can use slicing like original_list, smiley face, or the list constructor. For any object, including custom ones, you can use the copy.copy function from Python's built-in copy module. Dictionaries and sets also have their own .copy methods. Let's look at an example. Here, we have an original list containing numbers and a nested list. We create a shallow copy. Notice that the top-level lists original and shallow have different memory IDs, meaning they are distinct objects. However, when we check the ID of the nested list, original 2 and shallow 2, you'll see they point to the exact same memory location. This has crucial implications. If we modify a top-level element in original, like original 0, the shallow copy remains unaffected. But if we modify a nested mutable object, like changing original 0 to 300, you'll see that the shallow copy's nested list also changes. This is because both the original and the shallow copy share a reference to that same nested list. Now, let's turn to deep copy. A deep copy creates a completely independent new compound object, and it recursively creates new, independent copies of all nested objects found within the original. This means no shared references whatsoever between the original and the deep copy, even for deeply nested structures. To achieve a deep copy, we use the copy.deepCopy function from the copy module. This is your go-to when you need absolute independence. Let's revisit our example, but this time using deep copy. Again, original and deep lists have different IDs. Crucially, when we check the IDs of the nested lists, original 2 and deep 2, you'll see they also have different memory IDs. This confirms that the nested list itself has been copied, not just referenced. Now, if we modify original 0 to 300, you'll observe that the deep copy's nested list remains completely untouched. This is the power of a deep copy: full independence between the original and its copy, even for the most complex nested structures. So, when do you use which? A shallow copy is generally faster and uses less memory. It's perfectly fine for simple objects or when your object doesn't contain any nested mutable structures. Use it when you only need a copy of the top-level elements, or when you actually want changes to nested items to be reflected in both the original and the copy. A deep copy, on the other hand, is essential when you need absolute independence between the original and the copy, especially with complex, mutable data structures that have multiple levels of nesting. It guarantees that any modification to the copy, no matter how deep, will not affect the original object. The trade-off is that it can be slower and more memory-intensive. Understanding the difference between shallow and deep copy is crucial for managing mutable objects in Python and preventing subtle, hard-to-find bugs. Always consider the structure of your data and whether you need complete independence or just a top-level duplication. I hope this explanation has clarified these important copying concepts. If you found this video helpful, please give it a thumbs up, share it, and subscribe for more Python insights. Happy coding!